So today in this video we are going to solve one question which was asked in GATE 2003. So the question is, the n-type silicon is obtained by doping with, and options are A germanium, B aluminum, C boron, and D phosphorus. Okay, so before answering this question, let us go to a little bit background of this question, right? So like silicon based semiconductor, right? Silicon based semiconductor is of two type, right? One is known as intrinsic semiconductor, and another one is extrinsic semiconductor, right? So intrinsic semiconductor is the purest form of semiconductor where there is no impurity is added, right? This is pure form of semiconductor. Similarly, extrinsic semiconductor is a kind of a semiconductor where we dope this semiconductor with impurity, either, right, it could be a trivalent impurity or a pentavalent impurity. So extrinsic semiconductor is basically of two type. One is known as a p type and another one known as a n type semiconductor, right? So p type semiconductor we can get by adding, say, trivalent impurity, right? Trivalent impurity, and this is by adding pentavalent impurity, right? So when we add trivalent impurity, we get p-type material because there is one vacancy, right? In pentavalent impurity, we get n-type because there is the excess of electron, right? Further, this p-type is also factorized into two parts, which is non-degenerative and degenerative, right? Similarly, for n-type it is non-degenerative and degenerative. So what does non-degenerative and degenerative mean? So non-degenerative means, right, non-degenerative means when the doping, right, so in case of acceptor it is Na. So when the doping is less than equal to Nv, right, when the doping is less than equal to Nv, here Nv is charge density of this hole, right? Charge density of hole, right? Similarly, in degenerative, when Na is greater than Nv, that means doping is very, very high than the charge density of. Similarly, for n-type, non-degenerative means when your doping is less than equal to Nc, right, charge density of a space, right, of for n-type material, and degenerative is Nd is greater than Nc, right? So in simple term, I would say that when your doping is less and moderate, it is non-degenerative, and your doping is very high, then the occupied spaces which is available, right, for electron to occupy, the doping is higher than that amount, then it is called a degenerative. Okay, so now we'll go to see the materials which we use to make p-type and n-type material. Okay, so p-type material, right, and here we have n-type material, right? Okay, so for the n-type semiconductor, the material we use to make an n-type is basically these are the material, right? Right, so this is nitrogen, phosphorus, arsenic, antimony, and bismuth, right? And similarly for p-type, the material we use to make a p-type semiconductor, the dopant that we use to make a p-type is which is boron, aluminum, gallium, indium, and thallium. So these are the material that we use mainly for making of p-type material, and these are the material that we use for the formation of n-type material. So these are the doping basically that we use, right? So now we'll go to the question and see what other material is given for n-type, right? So here in question it is asked that n-type silicon is obtained by doping. So we have to make a n-type silicon, and the material, the dopant material, is given here. So the options are A germanium, B aluminum, and C boron, right? So for the n-type material, let me see, right, whether we have this material or not. So germanium, aluminum, boron. So germanium is not there, aluminum is not there, aluminum is actually here, boron is also not here, boron is here for the p-type material. So germanium, aluminum, and boron, these all materials are not for the n-type material. And now D is phosphorus. So phosphorus, let me see, so phosphorus is over here. So right, so the right answer for this question, right, to get a n-type material, the doping that we need to use, or the dopant we need to use to make an n-type material, is phosphorus. So the right answer for this question would be D. Thank you.